Let's find the prime factorization of this number. Now, I think I'll just use the division process to find the prime factorization of this number. How does the division process work? We simply find any prime number that divides into this number. Now, if you want some way of doing it each time, you can start with the number 2 and work your way up through higher and higher or larger and larger prime numbers. It makes no difference though. You may automatically see that 5 is a factor of 495 and start there. Let's look at this number, by the way. Is 2, the smallest prime number, a factor of this number? The answer is no, because 5 is odd, so 2 is not a factor. What's the next largest prime? That would be 3. Will 3 go into this number evenly? Well, remember it does if it goes into the sum of the digits. 4 plus 9 is 13. 13 plus 5 is 18. 3 divides into 18, so 3 should divide into this number. So if you'd like, you can start with 5, certainly. I'll go ahead and start with 3. 3 divides into 4 one time, remainder of 1. 3 divides into 19, 6 times 3. 6 times 3 is 18, so I've got a remainder of 1. And 3 divides into 15 5 times. Again, if you see 5 now and you want to use 5, that's fine. I'm going to see if 3 divides again. 6 and 5 is 11, plus 1 is 12. 3 divides into 12, so 3 will divide into this number. 3 into 16 is 5 times, and that's 15, so a remainder of 1. And 3 divides into 15 5 times. Now 3 won't divide any further here, but I know 5 divides. And how many times does 5 divide into 55? 11 times. You continue this process until the quotient is itself a prime number. So because this quotient is a prime number, I know 495 is 3 times 3 times 5 times 11. Or I can say that 495 is, I can write this as 3 squared times 5 times 11. And you can check by multiplying.